in sequence. I think you use one of mine. So if I'm multiplying these, 1, 2, 2, 1, the first one gives me 2 times 1 plus 1 times 2. So that would be 4. Nope, not inverses. It has to be a 1 there to be inverses. Okay, so that answer there must be 1, 0, 0, 1. If it's not, then you're okay. What about negative 1, 1, 0, negative 1 with negative 1, negative 1, 0, negative 1? Sure? Go through it. I get negative 1 times negative 1 plus 1 times 0. So that's going to be 1. Negative 1 times negative 1 plus 1 times negative 1. So that's 1 plus and negative 1. So that's 0. 0 times negative 1 plus negative 1 times 0. Well, that's 0 plus 0. So that's 0. Looking good. 0 times negative 1 plus negative 1 times negative 1, which is 0 plus 1, which is 1. Okay. And again, this work matrix or some sort of work showing, hey, this is where it's either not an inverse or yes, it is. That's going to need to be shown, okay, on your assignment.
But if you find a 4, you have to go.
You don't have to go on. You can stop right there. But just showing me that, hey, this is, I got a 4 here. It's not going to be the inverse matrix. We're done. Okay? Is that okay? Okay, so now finding inverse matrices. Here's a formula. So I'm going to use letters since it's a formula. The inverse of A, so we have matrix A, and it's going to be lowercase a, b, c, d. Is now how we write matrices. It's an a to the negative first power. So a to the negative first, that means the inverse of matrix A. It gets a little bit complicated. It's going to be, we're going to have a scalar 1 over AD minus BC. One over AD minus BC. What else do we call that expression right there, that AD minus BC from last week? A times D minus B times C. Not coefficient. That's a word we've thrown out there though, so. The difference between the product of the diagonal. Say it again, what? Yes. The determinant, discriminant. Determinant. That's the determinant that we did last week. Determinant. Inverse does not exist if it's equal to 0. Okay, it's kind of tiny down there. So that down there, that's why they call it the determinant, because it determines whether the inverse exists or not. Not everything will have an inverse. Dividing by 0 gives you an error. Okay. So the inverse is 1 over the determinant times this matrix, and we're just going to turn some things around here. D, negative B, negative C, A. Okay. So what happened to the A and the D originally? See how they switched on their diagonal? And what happened to the C and the B? They didn't switch, but they become opposites. Opposites. Don't say negative, opposites. Because what if it's already negative? Then this would become positive. Okay? Shoot, I should have left that on the top of the page. So let's find the inverse of that first matrix, coefficient matrix we had. 2, 3, 4, 5. So we did right. So if this is A, let's say A equals 2, 3, 4, 5. A inverse is going to be 1 over 2 times 5 minus 3 times 4. So that's the determinant. Remember the two diagonals and subtracting them. 1 over 2 times 5 minus 3 times 4. What's that going to equal? This is going to be negative 2 down here, so this is going to equal negative 1/2. Times, now we get to do the big switcheroo. Okay, the big switcheroo. So remember the A and the D flip spots. So instead of 2 up here, it's going to be a 5. 2 goes down here. So the 5 and the 2 switch, and the 3 would become negative, and the 4 would become negative. Now remember, this is a scalar, so you can just distribute through everything. So negative 1/2 times 5. I'm just going to say negative 5/2. Or negative 2.5. If it's a nice clean decimal, you can put it as a decimal. If not, leave it as a fraction. Negative 1/2 times negative 3. 3/2, 1 or 1.5. You could put that, but it'd be positive 3/2. Negative 1/2 times negative 4 is 2. Negative 1/2 times 2 is negative 1. Okay, you could check these by multiplying these back together. We're not going to do that now. Let's do another one. And then we'll come back and we'll use that to answer our equation from before. 3, 7, 1, negative 4. Inverse time. You get negative 19 for your determinant? To be negative 1/19 in front. When you're multiplying, it's a weird fraction, so I want you to leave this one as a fraction. So if it's negative 1/19 times negative 4, it'd be a positive. It's 1 over 19 times 4 over 1. That would just be 4/19. You can leave it like that. One 19th down here. This would be 7/19. This would be negative 3/19. So those two things are the two things you need to do. You need to work out by hand. It's just multiplying two of them to see if they equal identity, and then finding the inverse of a 2 by 2. Are those okay? Okay. Let's go back to our original question now. We had this matrix, and I made up these numbers. It's going to be probably a little ugly, but we'll see how it goes. So we had to solve 2, 3, 4, 5 times xy, and that equaled 6, 7. Was it 6, 7? 4, 7? Oh, it's 2, 3. Oh no! Man, I did the wrong one then. Alright. That's 2, 3, 5, 6, and that was 4, 7. Yeah, like, come on, Mr. Light. Okay, so we're going to multiply both sides by the inverse of the coefficient matrix. Now, I thought we would have already figured this out, but I gave you the wrong numbers earlier. So we're going to put the C, the coefficient matrix, and the